Hello and welcome to Level 1. We're going to build an extremely high performance router that's designed for you if you have an internet connection faster than a gigabit. So it turns out any potato class anything can handle a 1 gig internet connection, but we are seeing 2.5, 5, and even 10 gig internet connections that are rolling out. Most of the time you don't want a canned standard router. Those aren't really entering mass production in such a way as to be able to handle that higher performance, high-speed connection. If we look at the modems that AT&T offers, things like the Gateway 350-505, it's got a built-in ONT and 3 1 gig Ethernet ports and 1 5 gig Ethernet port. That's kind of trash. It sort of craps out when you've got more than 2,000 or 3,000 connections open. It wants to do NAT, it wants to do your wireless, it wants to do everything else. It's not particularly good at any of those things. Kind of sucks. So what are you going to do? Well, you can build a router. That's what we're going to do today. I did the Forbidden router, which is based on AMD EPYC. If you do that, it's going to cost thousands upon thousands of dollars. I'm going to show you how to do it a little bit more economically. So let's dive in. First, the easy button solution, which is not what I've laid out here. It'd be a system like this from Supermicro. This is sort of their 1U rack, short depth storage platform. I did a video on this separately. This is not Alder Lake, but this is a very fast Intel platform. This has 4 SATA bays. It has 1 x16 expansion slot. It has some onboard NICs. You can, Supermicro has this with up to 8 onboard NICs, and you can throw in a dual 10 gig adapter. This is almost too slow because you really want even more high-speed Ethernet devices if we're talking about, routing and doing security filtering and that sort of thing on a 2.5 to 5 to 10 gigabit internet interface in your house. But this is an easy button solution. You can just go buy this, load some software on it, maybe not install a NIC, and you're good to go. I'm going to show you how to build one though. And it's probably not going to be cheaper than that, but it will be a little bit newer. This is the Gigabyte MW34SP0. This is an incredibly cost-efficient W680 motherboard. W680 is a workstation chipset for Intel Alder Lake, that's LGA 1700, and probably soon some other LGA 1700 CPUs. This is a DDR4 motherboard, so you're going to be able to get inexpensive DDR4, but it also supports unregistered error-correcting memory. And Alder Lake CPUs, the desktop CPUs, like the 12500, support error correction. Now, I'm going to be using, not the i3-12100, this would also be a really good choice. I'm going to be using the i5-12400. Why? Because you can get that, the 12400 at Micro Center, for like $110, $120. That's 6 Alder Lake P-cores. The whole reason that we're doing this is because we really want Alder Lake or newer. The reason we want Alder Lake or newer is because those P-cores, the performance cores in the Alder Lake architecture, are incredibly high performance, especially when we're talking about network tasks. A lot of the time when we're talking about a high-speed file server, high-speed, packet routing, that sort of thing, when we're not talking about specialty hardware, that is an application-specific integrated circuit, we're talking about a general-purpose compute, you want that single-thread performance to be as fast as possible. That's going to be minimal latency, highest performance, highest throughput. This is a relatively inexpensive, desktop workstation class Alder Lake motherboard. We're going to pair this with the 12400, which has 6 Alder Lake P-cores. If you saw our other Alder Lake platform, we're not even going to install a routing platform on this. We're going to install a virtualization platform and then actually deploy our router as a virtual machine, which is the forbidden part of the Forbidden router. But if you want to do something a little bit more pedestrian with this, you totally can. Meaning that you're going to deploy pfSense on this, or OpenSense, or OpenWRT, or some other distribution of FreeBSD or Linux to actually do your routing and your internet traffic and your filtering. We have got a bunch of guides for that kind of stuff on the Level 1 forum. We'll come back to that. We'll talk a little bit more about that in a second, but I just want to sort of run through your hardware options here. This motherboard has onboard 2.5 gig. It's only a single onboard 2.5 gig NIC. It's got onboard audio. It has DisplayPort and HDMI out for the iGPU, but you don't really even need that. It has an ASpeed 2600 for remote management, and that's what the other NIC is at the rear I/O here. And it's also VGA out for that. The other thing is our case. This is a really, really nice, incredibly high-end Sliger 3U case that I've put an EVGA SFX power supply in. It's 550 watt. This case will work great with SFX or SFXL power supplies. Generally, I recommend SFX. We use the same case for our AMD EPYC-based Forbidden Router build that we did a while ago. We're going to use it again, and this is actually the most expensive component because I want something that's nice looking and rackable, and this is a very nice looking case. It's very well designed. It's very thoughtfully designed. They didn't pay me to say that. I literally paid for this with my own money. But I am hoping that I'm going to get some other variations of this case soon to show maybe what this would look like if we were going to go for 3.5-inch drive storage. Because this case is a great case for everything, unless you want a home server that has a whole bunch of 3.5-inch drives. And I have some other models for that, so I'm probably going to pick up one of those because I was trying to do the whole all-flash NAS thing, but I found my media collection sort of exceeds what I'm willing to pay for all-flash storage. So here we are. You might be thinking, our Gigabyte platform is pretty limited in the networking department. There is a version of this that has a high-performance onboard SFP. You can look around for that. Maybe that'll be available in your area, maybe not. But I did a video called, cheat codes for doing this kind of thing. This is one of those cheat codes. This M.2 module, it's about $40 US. You can pick it up at AliExpress. You can get it on eBay maybe for a little bit less. There's a few resellers here in the States. Maybe it's something I should carry in the Level 1 Tech store. But this is an Intel i225V 2.5 gigabit NIC. And it can be installed in an M.2 slot. And then you have more 2.5 gig connectivity. This is pretty awesome. This motherboard also has 8 onboard SATA connections, 4 of which share lanes with one of your M.2 slots. But one of your M.2s is connected directly to the CPU, and the other 3 go through the chipset. Now they make single and dual 2.5 gig, and a little bit more rare, but you can get a 10 gigabit M.2 as well. Those are a little harder to find, they're a little more expensive. The best deal, the best thing to do if you're in the home internet scenario is the Intel X550 T2. This is a fabulous 10 gigabit Ethernet card. Intel really, like this genre of Intel, they really shined. It's an incredible networking platform. The earlier X550 T2s can be a little troublesome when you want to link up a 2.5 and 5 gig. Strictly speaking, they need a firmware update. And Intel doesn't call it a firmware update, they call it an NVM update, non-volatile memory. It seems as though if you install the driver on Windows, that it will update the NVM to make 2.5 gig work. It's a very weird thing that happened. When I was setting up for this video, I had some of these like basically launch day X550 T2s that I pulled from systems that were originally servers for upgrades. And the X550 is the oldest card. If you want to get like a 700 series Intel Ethernet NIC, that would be even better. The problem is that 2.5 and 5 gig. A lot of those ISP connections, the hardware they provide, such as the aforementioned gateway from AT&T, will only link up at 5. They won't link up at 10. And the auto negotiation on these cards, because they're so old, kind of sucks. They want to do 1 gigabit or 10 gigabit, but not 2.5 and not 5 gigabit. The NVM update resolves that. The other wrinkle, the other problem that exists with that is that when you're, Intel and making a bajillion of these, HP wants a special version for their servers. Dell wants a special version for their servers. And so you have to be careful about that on eBay because the NVM update for the Dell version of this card that you would, have has to come from the Dell website, which is basically impossible to find because anything older than 3 years, Dell basically writes off, and it's almost impossible to find the Intel NVM update for some of the Dell versions of these cards, or HP. The retail version you can find on Intel's website, thankfully, and that works really well. So you have to run a command line utility either in Linux or FreeBSD or Windows, and it'll detect the card, it'll apply the NVM update, and you're good to go. But this is by far the most economical option that will give you the 2.5 or 5 gig link speeds that you might need for your ISP's equipment when your ISP's equipment won't necessarily do raw 10 gig. Sometimes, depending on your ISP, you may be able to do a direct SFP plus connection or a direct, fiber optic SFP plus transceiver. That is a much better situation. You're not required to have ISP hardware. That is by far a better situation. That's strangely the case with AT&T's 1 gig stuff, but is not the case with their 2.5 and 5 gig stuff. You're required to have their crappy modem because the crappy modem can't really give you the 5 gigabit service, I guess, in all scenarios. In terms of cooling, when you pick up one of those retail CPUs, it's going to come with this very modest, let's say, CPU cooler. This is fine. You don't need anything more advanced than this. This is going to work fabulously in our Sliger 3U case. If you don't want to get the case and you want to save, a few bucks and just throw it in a cheap ATX desktop case, you could totally get a $50 cheap ATX desktop case with a really inexpensive power supply and be ready. This CPU, budget 300 watts for an Alder Lake CPU for your power supply, so definitely don't go under like 350 watts for your power supply. But Alder Lake's also very power friendly when it's not being heavily loaded. So when your router is not super heavy under load, you're probably looking at like a 25-30 watt nominal draw, assuming that you add the NIC and some other things, and probably no mechanical storage, because those are like 10 watts each when they're running. Now for the software stack, my primary recommendations are pfSense and OpenSense. Those are based on FreeBSD. They work really well on Alder Lake, and all this works really well. If you opt for the i5 or anything beyond the 12400, be aware that P-core and E-core handling, you have your P-core for performance and your E-core for efficiency. I don't think the E-cores really give you anything at this scale. Even if you're going to run the virtualization software, even if you're going to run a bunch of virtual machines, 6-core is overkill. I'm going to run a Docker machine and have Pi-hole and Portainer and just go completely nuts with virtual machines. 6 cores is fine because those 6 P-cores are insanely fast. For Linux-based distros, newer versions of the Linux kernel can use those E-cores a little bit better than FreeBSD. But again, for this application, for this scenario, I don't think those E-cores really give you anything. And if you have any anomalous performance or any anomalous behavior, just disable your E-cores. One reason that you might move up to some of those higher end processors is because according to Intel Arc, that i5 is going to support error correcting DDR4 memory, but only when you use it with this W680 chipset. You couldn't take advantage of error correcting memory on a desktop platform. Do you really need error correcting memory in your router? That's a whole other debate. I would say that it's a nice to have, but it's definitely not a requirement. I'm going to have it in mind. You do you. That's a you thing. It's totally fine. There is one other thing I'll mention. This is an MSI 10 gigabit adapter. This is actually an Aquantia chipset. And so Aquantia is another reasonable 10 gigabit Ethernet interface that also works at 2.5 and 5 gigabit. So if you can't get the X550 or the X550 T2 is too expensive, you can pick up these, and they work pretty well. But this is only a single NIC on this PCIe card, and this is only, I think there's a PCI Express 2 PCI Express lanes, yeah. So it's not really making efficient use of your 3 physical slots that you have on your motherboard. It is worth mentioning that when we're talking about 10 gig and beyond 10 gig, maybe you want to go for 25 gig, it's really not super efficient to do that with a CPU. It's super inefficient to use your CPU to shuttle those packets around. It's worse in terms of latency than other hardware. It's worse in terms of software complexity and a whole other thing because the platforms really haven't super caught up yet. But that's also part of the reason why I would recommend using Alder Lake versus an older platform. In the past, our internet connections were so slow that we could use a garbage tier computer from 10 years ago and have a much better internet routing experience. But today, with a fiber optic internet connection and something that's very low latency, you want to service the packets in and out of the machine as fast as possible. And with connections that are exceeding 1 gigabit in speed, it's a little bit more difficult to have that super amazing positive user experience on older hardware. Alder Lake is brand new. It's only been out for not even 2 years. And this is sort of what I feel like you need if you are on the upper high end of what's available in terms of internet connections. If you're rocking Starlink and you're getting, 100 meg down and 20 meg up, you don't need this. Something like the 1U Supermicro is even a really, really good experience. But for something that is a little higher end, you want to run Pi-hole, you want to run virtual machines, you want to run Steam Cache, that kind of thing. This platform is fabulous for that. You can, everything that I showed you how to do in the Forbidden Router video, you can also do with this platform way more economically, including error correction and everything else. Anyway, that's enough chatter. Let's get this thing put together. There's our i5-12400 installed. The cover removes itself. Go set our i3 over there. I've got another project in mind for the i3, and that's what we're working with for this build, or at least the start of it. Not bad. And in case I didn't mention it before, one thing I really like about this 3U case is that you get full height cards. These are what's called half height cards. See, they're only this tall. This is a popular thing in servers, but I've got a full height bracket on it, and this is a full height case, so you can use big peripherals. Now this Sliger case also has a 5¼ inch expansion bay, in case that wasn't obvious. You should check out the separate review that I did. But this bracket will also hold, low profile 2.5 inch drives. There's some room underneath it. You got quite a bit of room in this case for additional internal drives, which I am going to take advantage of, although maybe not in this particular build. If you do see older NICs like the Intel X540, I mean, that does work at 10 gig, but you're not going to be able to run 2.5 or 5 gig with the X540, only the X550 and newer. Sorry for all the server room noise. Not really server room noise. I actually brought this out of the server room for testing and kind of a follow-up because sort of the low-cost Forbidden Router. All right, what's the verdict? First, I'm blown away. 6 P cores, this CPU is around $100. This blows the doors off of any previous generation Xeon that I've seen. I was a real enthusiast about like the Xeon 1230 and like the V2, V3, V4 with their incremental improvements. This is dramatically different. This actually puts like the Broadwell, like the V2, V3, V4 even, Xeons to shame. This 6-core, I would rather have than a Broadwell V4 dual 6-core or even a dual 8-core because it's that monstrous. Now the Gigabyte motherboard is in short supply, but it is an incredible motherboard. Would it make sense to do a group buy, a level 1 group buy for this class of server motherboard? I mean, I could do a Kickstarter and we could do that if that's something you're interested in. I think this or the AM5 socket maybe for like the home server thing. You could go more than 6 P cores. You could go as far as I think the 12700K. I wouldn't do the 12900K because the E-cores don't really give you a lot. In this case I'm using XCP-NG. It doesn't really give you a lot of awesomeness mixing those P and E cores. The kernel being what it is and the scheduler and some other details. If you're gonna do that, I would recommend that you run vanilla Linux. Vanilla Linux can take better advantage of the mixed P core and E core situation on those CPUs. And that's gonna be doubly true with a 13900K. I mean, that 24 core monster, 8 P cores and 16 E cores, that should be an incredible home labbing platform on a motherboard like this. But the fly in the ointment is the hypervisor support and all of the little detailed minutia that goes into that, because I can tell you right now, VMware and Microsoft, those companies, they are not putting any work at all into making sure that everything runs correctly in terms of picking which core, what workload goes on. You're only going to experience that with the vanilla Linux kernel. You've got a shot at something like Proxmox and maybe to a lesser extent XCP-NG working with that, but I got to tell you, those engineers aren't really working on that either. I've got a thread on the XCP-NG forums which has gone ignored for a year and a half, 2 years, where Turbo doesn't exactly work correctly on AMD CPUs. I mean, it's not that it doesn't work, it just doesn't work as well as it should. There's some kind of oversight or some kind of problem in the Zen kernel where it just doesn't turbo as high as it could, at least on bare metal, at least with a vanilla Linux kernel running something like KVM. Maybe it's just the way that Zen works, and the trade-off really admittedly isn't huge, but that kind of a problem is only compounded when you've got mixed P and E cores. All of that aside, this is an incredible, incredible platform. We did iPerf testing just for giggles, tested this with a 5 gigabit ISP and it had no problem completely saturating the link, actually even past 5 gigabit. The technician from the ISP said he'd never seen anything that fast. We also tested this, of course, with vanilla 10 gigabit Ethernet, just using our Arista switch here, which is also old school 10 gig Ethernet, to our kick butt, dual Milan X server. Now, of course, the Milan X server is going to be better in every single way. Our original Forbidden router is thousands and thousands of dollars of equipment. Of course, it is superior, but this little tiny router with its $100 CPU can hold its own, not just at 10 gig. It made me curious. I also went to 25 gig, and yes, the plucky little P-cores can saturate a 25 gig connection with iPerf. SMB is a different story. It can't saturate it can't saturate 25 gig with Samba unless you go multi-channel, and it's going to use more than one core. And then yeah, it absolutely can saturate 25 gig, but you're using a lot of CPU when you do that. But just raw iPerf with the hardware acceleration using a Mellanox ConnectX 4, I think it was, not a problem. So that's very, very impressive for this platform. If you want something like this to be your router and your Docker host and storage and everything else, it absolutely can do it. And it looks Lilliputian in our 3U Sliger case as well. So very impressed with this motherboard, very impressed with the platform, very impressed with Alder Lake P-cores sort of wearing two hats in this sort of server role. I'm surprised that it works as well as it does. 13th gen, if there is something similar to the 12400, which there probably is going to be, 13400, and it has the similar larger cache, that's also probably going to help in these server workloads. More cache will help you where the E-cores won't necessarily help you. But this has been a really interesting look at this platform. If you have any questions about this or anything that you want to run, test, whatever, I'm Wendell, this is Level 1, I'm signing out. You can find me in the Level 1 forums, and that's where you can ask your questions and whatever else. All right, it's a bit loud, I'm getting out of here.